multiplication rule for independent events. Our objective, we want to use the multiplication rule for independent events. Let's remind ourselves what we know. We know the definition of probability, a measure of the likelihood of a random phenomenon or chance behavior occurring. We know that the addition rule applies to the OR probabilities, and it involves adding. And we know from grade school that when we have numbers that are between 0 and 1, and we multiply them, the product is a smaller number. Okay, that's going to come in, be important here as we work with this. Okay, so what are independent events? Two events, E and F, are independent if the occurrence of event E in a probability experiment does not affect the probability of event F. All right, so what is the multiplication rule for independent events? If events E and F are independent, then the probability of E and F occurring is the probability of E times the probability of F. In other words, we multiply the individual probabilities. Notice the word and. Okay, we spoke up here. When we have the word or, we add. When we have the word and, we multiply. Okay, all right. And so let's take a look here and see how this one works. All right, in the game of roulette, the wheel has slots numbered 0, 00, and 1 through 36. So there are a total of 38 slots that you spin the ball in, and it lands in one of those 38 slots. A meadow ball rolls, it looks like I misspelled. A meadow ball rolls around a wheel until it falls into one of the numbered slots. What is the probability that the ball will land in the slot number 21 2 times in a row? So notice we're doing two things. We're going to play this game twice. Okay, so this is where the and probabilities come into play. We're doing more than one thing. Okay, so I like to write this down with the word then. So the probability of getting a 21 and then getting another 21. So I like to have the word then in here next to the word and. Okay, we already know how and works, but this is saying we're doing two things. We're going to do this, and then we're going to do this. We have two separate, in this case, rolls taking place. Well, according to the multiplication rule, that's the probability of getting a 21 times the probability of getting a 21. Well, what's the probability of the ball landing in the slot 21? Well, that's a 1 in 38 chance. And it's the same thing for this one, 1 in 38 chance. We multiply those two numbers and we get a very small number. We've got 3 zeros after the decimal, and then I'm going to put 693 here. That's pretty small chance of having that ball land in the 21 and then land in the 21 again. This is 0.07%. Not a very high percentage. Okay, so let's notice here. When we multiply probabilities, we get a smaller probability. Okay, the product is smaller. So to have two things happen in this case, a 21 and then a 21, we are decreasing the chances of it happening. Okay, we've shrunk the possibility of it taking place. All right, let's take a look at another example, and then we'll recap this multiplication rule. A single die is rolled twice. Again, notice we're doing something more than once. In this case, we're rolling the die twice. find the probability of rolling a 1 the first time, and, there's that word, a 5 the second time. So, probability of rolling a 1, and again, I like to put the word then, and then rolling a 5. This is telling me I did two different things. I'm going to first try to roll the 1. I'm then going to pick the die up and do a second event and try to roll the 5. I want to roll a 1 and then roll the 5. The and tells me I'm going to multiply. Okay, so this is the probability of rolling a 1 times the probability of rolling a 5. What are the chances of rolling a 1? 1 in 6. What are the chances of rolling a 5? 1 in 6. Now, if I roll the probability of rolling a 1 and then a 5, I've shrunk. You know, it takes a lot to do this and then that. Okay, it's going to be harder to do this and then that. So the and probability makes things more difficult. Therefore, the probability is decreasing. And as you can see, the product is 1 out of 36, which is smaller than the two individual events together. And that is the same as 0, 2, 7 repeating. Okay, so let's summarize what we've got here with the multiplication rule for independent events. It applies to the and probability questions. And again, I like to use the word then to keep me straight that I'm doing more than one thing. The probability of this and then that. Okay, again, contrast this to the addition rule, where we only did one thing. Now we're doing more than one thing. We're doing more than one spin, more than one roll. We're making more than one choice, etc. In these cases, because we're asking more things to happen, we're reducing or decreasing the probability of success. Okay, so we're going to wind up with a smaller probability, hence multiplying, because multiplying results, when we multiply two numbers that are between 0 and 1, we end up with a smaller number. With numbers that are between 0 and 1, a fraction or a decimal, the way to get a smaller number is to multiply. Thus, and probabilities involve multiplying. So there you have it. We worked with or probabilities, one roll or one event happening, and we're going to add. And we've worked with the multiplication rule, the word and for and probabilities. We're doing more than one thing, and we're going to wind up with a smaller probability, so we multiply.